Okay. So, were there anything that you want me to go over in terms of the homework over conversions or applications of percentages?
The 13.
And I heard that there were some numbering issues that were incorrect on the homework page numbers. Is that correct?
It just didn't line up with
They didn't line up. Yeah, I've had that problem. Just keep track when we're in class and we're going over certain sections. Just that you're to do the homework that immediately follows that section. It'll say on there, it'll say homework. Usually it's separated. See, so here's the homework for conversions. And then it'll start the next section after this. Where is it? So here's linear graphs. That's new concept. And then homework is after that. Okay, so which one?
13.
Out of the conversion section? Is that the one Spain? That one? All right. Okay, I think everyone can see this. Let's see. Let me make that a little bit bigger. Spain is 504,646 square kilometers, and France is, what is that? 640,679,000,000 square meters. So which one is bigger? All right. So how do we do this?
Don't we want to convert one of them to be the same?
Yeah, so we either need to make this one be square meters, or we need to make this one be kilometers, right? Kilometers. So which one? Do you want to take the France and make it kilometers? Do that?
That's what I was going to do.
Okay.
I got confused.
Okay, so let's start with that. We're going to be trying to get from square meters over to square kilometers, right? That's our ultimate goal here. So if I take 640 billion, 679 million, 000,000, square meters, then how can we get that over? So I talked about this in class, that when you have square units, that it's a little bit tricky, all right? So the way that I would write this is I would first create my unit fraction, so I'd put this over 1. And do y'all remember what I did with the square meters?
You put one meter there. And
Yeah, so I'm going to take away the square meter. I'm going to make that just meters and then 1 meter here. All right? And then from here, now I try and convert each of these 2 different meters over to kilometers. So how do we go from meters to kilometers? Now, in the metric system, you just move decimal points, right? But let's do a conversion factor. Do we know how many meters there are in a kilometer? So we go back up to the table.
Yeah.
So let's go to the table and take a look. I'm going to do a conversion factor instead of moving decimals, because it works exactly the same way. So, okay, so meter here, this is our basic unit meter. A kilometer is how many of those basic units? It's 1,000, right? So there are 1,000 meters in 1 kilometer. Does that make sense? Okay, so let me go back to this. 1,000 meters in a kilometer. Well, I think I passed it up, didn't I? Yeah. So I'm going to write that down here. There are 1,000 meters in 1 kilometer, right? So remember, I can create 2 different fractions from that, right? So I want to get rid of meters, so that means I want meters on the bottom. So to write this as a fraction with meters on the bottom, I put 1,000 meters on the bottom and 1 kilometer on top. And then one of my units of meters will cancel out, right? Then I have to do it again, right? Because I have another meter to cancel. So I do 1 kilometer, 1,000 meters. And again, the meters cancel. And now I will get kilometers times kilometers, which is kilometers squared, which is what we're trying to get to. So now you can multiply straight across if you want, right? So if we do this straight across, we should get 640,679,000,000 kilometers squared divided by, and if you do 1,000 times 1,000, you should get 1,000,000. And now you do that division, and when you do that division, you should get 640,679 kilometers squared. So I'm just trusting that on your calculator you could do this part. Is that fair or no? We should get all 6 zeros to cancel out and just be left with this. So this is France, right? So France is 640,679 square kilometers. In Spain was 504,646 square kilometers. So France is bigger, right? Yeah. So essentially you're going from square meters to square kilometers in metric. Really, all we did was move the decimal point 6 times, didn't we? That's because we had to go from meters to kilometers twice. So it's like we move that 3 and then we move it 3 again. But this shows, I guess, in more detail what's happening, all right? Okay, other questions?
Yeah, on the percent.
Percent homework? Okay.
There's 5, 6.
Let me see if I can get to it first.
Okay.
Number 5, is that what you said?
Or 6. Maybe 2 or 6.
6?
Yeah.
Okay. So number 6, Mary has swim practice 20 out of 28 days in February. What percent of the month of February have swim practice? All right, so remember, just like we did with the iPhones in here, you want to take the, what you're counting, in this case, is the number of days of swim practice and divide it by the total number of days. So how do we do that first part? Or the percent part here? I guess what confused you on it?
Well, when I did it, I got as far as setting it up. But
Did you do 20 divided by 28?
yeah.
Okay, and what did you get there? Oh, where did that go?
27 was
Okay. And then you're supposed to convert that, right, over to, there it is.
over twice, I think 71%.
Yeah. Yeah, so this is approximately 0.714, I'll go 3, like that. And then you convert that to a percentage, so you move that over 2 places, 71.4%. I think they went it to the nearest tenth of a percent, so that would be the first decimal place. Did that not match what was in the back or in the solutions?
Honestly, I just think I didn't convert it into
Okay.
percentage.
Okay.
Okay.
Anything else? Did y'all have any issues with these proportions?
Yeah, can you?
Yeah, I can do a couple of these because we really didn't do these in class. So these proportion problems, we're trying to solve for the variable.
Okay.
All right, so take a look at this first one. 30 over t equals 5 over 3.4. All right, so anyone that did do this want to share how they did it? Okay, who was that? Yeah, what did you do?
Cross multiply.
Cross multiply, what is that?
I put t times 5.
Okay, so you multiplied across here like that, and then across here like this. Okay, that commonly you'll hear students refer to that as cross multiplication, and that is allowed so long as you have a fraction equal to a fraction. You're allowed to do this, all right? The only time it would get dangerous is, let's say you had this, just for the sake of showing you some things to be careful with. Like let's say you had that and you were asked to solve for t. You cannot cross multiply here, all right, because this plus 1 causes a problem. You have to have fraction equals a fraction, then you can do it, all right? So I'll stick with that. So you got on your calculator and you did 30 times 3.4, right? So 102. Put that on this side, then equals, and you did t times 5, so 5t. Okay, then what did you do?
I divided by 5.
Yes, why?
Because the t you can't.
That's
divide
right.
by 2.
That's right. You're trying to get t by itself, right? So you want to get rid of the 5. It's being multiplied, so you divide both sides by 5. And we're probably going to get a decimal here, yeah, 20.4. There we go. Make sense?
Yeah,
Okay.
can you do one like how you were showing right there with the plus?
Now this would be different. Okay, so for this one, what I would do is I would have to multiply by the least common denominator.
Okay, so you're just gonna go one over 1 and then.
Yeah, I would make this look like 1 over 1. And then I'd actually multiply this, and this by 3.4t. Because 3.4 here, we need that in our common, that's our common, and then we need a t, and then a 1, and 1's already here. So if we take that and imagine distributing that here and here, but then also doing it on this side, 3.4t over 1, then you should be able to work it that way. But see, it's not cross multiplication.
Yeah.
Yeah.
I guess it's just the t's and all that. It just confused me a little bit.
So I think all of these could have been done this way, right? So cross multiply, cross multiply, cross multiply. Anything else before we move on to the next topic? All right, maybe at the end, if you have anything else that you can think of, we can address it. I want to get to lines. All right, so to start this off, let's just talk a little bit about lines. And the graphs of lines. All right, so when it comes to lines, we all know what a line is, right? I mean, that's obvious for all of us. But when we look at a line visually, there's always an equation that goes with that line. And there are two standard forms for linear equations. I'm going to put them on the board here. The first one is this. AX plus BY equals C. Okay, this is called your standard form of a line. And in this standard form, the A, the B, and the C are just numbers. So I'll give you a specific example of a line in standard form. 3x minus 2y equals 12. So that is a standard form of a line. So what are the main characteristics? Well, first we have to have, in order to be a line, we have to have an equal sign, right? Right, so we have to have an equation, which we've done equations already, haven't we? But the equations we've done have had just one variable in them. Here, we have two variables. This is a variable, and this is a variable. So we have x and y both appear in the equation. When you have two variables and an equal sign, you're looking at a line. Now there's also something I should point out. These equations, that x is raised to the first power, that y is to the first power. We don't have to write that, but if we see like an x squared in there, it's no longer a line. All right, so two variables, an equal sign, as long as the variables are raised to the first power, we have a line. All right? So that's the standard form of a line. And then we have another form, which we like to work with, and this one is called the slope-intercept form. So if you see something that looks like this, y equals mx plus b, this is called the slope-intercept form. And for this one, m and b are numbers. So do we still have an equal sign there in that slope-intercept form? We have an equal sign, right? Do we have x and y in there? Two variables? Yes? Okay. And then these are numbers. So I'll give you a specific example of this one. Y equals negative 3x plus 4. All right? So now what I've done is I've replaced this m with some number I've made up, and I've replaced the b with some number I've made up here in this case, negative 3 and 4 respectively. So when we say that these are lines, we need to kind of get an idea of what we mean by that. You know, like why does this equation represent a line? So I'm going to kind of erase this and we're going to start from scratch, and I want us to kind of think about this from a perspective perhaps you haven't thought about it before. So right now I'm going to put an equation up on the board. Let's go with this one. What was the one I had? 2x, was it plus 3y or minus 3y equals 12? The first one?
The first one was minus 2y, 3x minus 2y.
Oh, 3x minus 2y. Okay, let me do that again. 3x minus 2y. So that first equation I gave you, that we know that that's a line in standard form. But let's talk about why it's a line, all right? So can somebody just think of an x and a y? Okay, give me an x and a y that would make that equation true. Somebody give me an x and then give me a y that make the equation true.
2 and 3.
2 and 3, let's see. If I let x be 2 and y be 3, will that work? 2 here for x, 3 times 2 is 6. Minus, well, I'm not quite sure it's going to work.
Yeah, I was thinking as addition when I said that.
So why don't we change this to negative 3? Would that work? So what's 2 times 3 here? Let's do that. 3 times 2 minus 2 times negative 3. What does that equal to? So that's 6, right?
Oh, okay.
And then now this is going to be negative 6, but then I'm subtracting it, so that'll be plus 6, so that'll be 12, won't it? And that works, right? So that would work. But is that the only answer? Okay, can you give me another answer?
4 and 0.
4 and 0. Okay, so x is 4 and y is 0 would work, right? And should I check it? Yeah, 3 times 4 minus 2 times 0. 3 times 4 is 12. Take away nothing. Yeah, that's 12 also. All right? And then we come up with another answer. Let's do one more. How about I force you to do it? How about if x is 0, what's y? Negative 6. Y has to be negative 6. Check it for yourself, but that works. All right? Now, we could do this all day, couldn't we? Do y'all agree that we could come up, there's an infinite number of answers to this.
Okay.
So what we want to do is we want to try and visualize these answers. Now, think back to an equation like this. 3x minus 4 equals, let's say 5. Think about that equation. Look at the difference between this one and that one. This one variable, right? When we solve this, you know, we would add 4, we would get 9 over here. Here we'd have 3x equals 9. We divide both sides by 3 and we get x is 3, right? Agree? Yeah, so this is just one answer. There's only one number that makes this true. But there are an infinite number of these pairs that make this true, right? An infinite number of x's and y's that I could come up with. So we want to try and visualize what's going on here. So what we do is we draw a picture. Our picture looks like this. We say, okay, this number line, 0, 1, 2, 3, these are going to represent our x's. And then we're going to take a number line like that, make a copy of it, and tilt it and put it up. I know you've seen this before. This is our y-axis. I'm just trying to get you to understand, like, from a different perspective, I think. Hopefully it's different. So when we draw two axes, one representing our x and our y, then when we come here to our first solution, 2, -3, what we're saying is to visualize that answer, what we do is we let our x be 2, so we go out 2, and then we go down 1, 2, 3, and we put a dot here, right? And this dot represents one of the infinitely many solutions to that equation. And then this one would be another one, right? X is 4, y is 0. So we go out 1, 2, 3, here's 4. There we go, right? And then we have another one, 0, -6, which I'm going to go off the camera for sure. -4, -5, -6, right? So 0 on the x, down 6. And it's not perfect because I'm drawing on a board here. But if we connect these, you can see, well, it's actually pretty good. You can see that they lie on a straight line, right? And every answer that you would ever pick would always lie on this line. There's never going to be one that just is over here somewhere. So if we were to be able to get all the answers to that, if we could somehow fill in every single one of these dots, we would get a solid line the whole way, right? So that line actually represents an infinite number of dots, and those infinite number of dots represent the infinite number of solutions to that equation, all right? All right, so if I asked you right now for someone to get up on the board and draw me a line, you know, the minimum that you would need would be 2 points, right? If I give you 2 points, you can draw a line through them, correct? If I give you 1 point, that's not enough, right? So 2 points, you can draw a line. So what we're going to be doing here is I'm going to be giving you an equation, all right? It's either going to be in standard form or in slope-intercept form. And once I give you an equation, I'm going to ask you to graph the line. And there's normally 2 different methods to do this, all right? So there's two different common approaches to it. The way I did it here, by us just kind of thinking about numbers, this is not the way we're going to do it, all right? This is just to get us to understand what a line is. So I'd like for us to start this over, same problem, okay? I'm going to erase this. And we're going to talk about lines. Let me just start. We're going to talk about lines in general first before we go and do that one. If you have a line, if I right now ask someone to come up here and draw a line, just arbitrarily, they just draw a line here, all right? Do you all agree that that line has to hit the x-axis and the y-axis somewhere? As long as the line is not what? Because there is a way that you can avoid hitting those. How could I avoid hitting the y-axis? What if I do a vertical line, right? If I do a vertical line, it will only hit the x-axis. And if I do a horizontal line, it will only hit the y-axis. But any other line that you draw, no matter how you do it, as long as it has some sort of tilt to it, it's not straight up or straight across, it's got to hit the x and y-axis somewhere, right? So these points where we hit, we call this the x-intercept, and we call this point the y-intercept. Can somebody tell me something about every x-intercept and every y-intercept? You know one of these. This is the x and this is the y. So can you tell me on the x-intercept, can you tell me what is always going to be true no matter what if you're on the x-axis? The y is 0, right? This y has to be 0. Because how far up and down are you going to move? You're not, right? So the x-intercept will always have a y value of 0. What about the y-intercept? Your x, right, your left and right will always have to be 0. Agreed? And the only thing that's left for us to figure out is what is the x value here that corresponds to a y value of 0, and here, what is the y value that corresponds to an x value of 0. So when we're asked to graph this, the first approach, okay, the first method that we will use is called the intercept method. And basically what it says is we are going to go find these 2 points. Once we have the 2 points, we can draw the line, all right? So the first intercept we're going to go find is the x-intercept. I'm just going to put x-int from here on out. And to find the x-intercept, what do we say about the x-intercept? What do we know when we're talking about an x-intercept? That y is 0. So what you're going to do is you're going to go to your equation. You're going to set y equal to 0 in the equation. And then you will solve for x. I'm sure that a bunch of you already knew that coming in here, that if you want to find the x-intercept of a line, you set y equal to 0. But I hope that this gives you some idea of why we're doing that. All right, so let's set y equal to 0 up there. And what are you left with when you replace y with 0? What is left after you do that? You get 3x equals 12, right? And now you have a linear equation with one variable in it, and we can solve this for x. So how would I solve for x here? Just divide by 3. So if I divide both sides by 3, I should get 4. So here's what I can say about the x-intercept. I'm going to just put the answer here. The x is 4 and the y is 0. We knew that, right? We knew the y was 0, and we figured out that the x was 4. So that is a point on our line. Now we have 1 point. We're going to go get the second point. So how do we get the second point? How do we get the y-intercept? You set the x to 0 and solve for y. So you do the opposite of what we just did. So I'll do that up here. So we're now going to find the y-intercept. We're going to set x equal to 0. We're going to solve for y. So let's set x to 0. Okay, so we know that that's going to be 0. So the remaining equation is negative 2y equals 12. And then what do we do there to solve for y? Divide by negative 2, right? Negative 2 divided on both sides, we get negative 6. So what is the point that we have for the y-intercept? What are its coordinates? What's the x, what's the y? 0 and then negative 6, right? There we go. That's all we need, 2 points, right? 2 points, you can draw the line. So let's do this right here. I know that I'm going to have to go out to the right 4. 1, 2, 3, 4 on the x-axis, right? Here's 4 on the x-axis. I'm going to put a dot. And then here is my y-intercept, so that just means I'm going to go down 6. So 1, 2, 3, 4, 5, 6. Down 6. I put a dot, then I get out my straight edge, and I draw a straight line through those, and I have graphed the line. Right? That is the first method for graphing lines. And all it is replace one of them with 0, solve for the other one, then do it the other way around. Once you have that, you're good. Questions on that?
Do we always have to find the x and the y?
Well, you need 2 points, right?
Yeah.
So if you just found 1 point, there's an infinite number of lines that go through that point, right? So you need another point to be able to draw me a straight line. So you have to do them both. Yes. If you're using this method, yes. Okay? Now there is a way to draw a line with only 1 point, but that's the next method. All right? All right. So now I'd like to kind of introduce that to you. So what I want you to realize is that when you're on this line, right, let's say that you're here and you want to get to this point right here. Of course, you could just walk out like that, right? But another way to do it would be to go up and over. Up by a certain amount and over by a certain amount, right? So how much would I have to go up by to get here? Have to go up by 6, right? And then how much would I have to move to the right? 4, right? So we have this thing, when it comes to lines, we say the slope of a line, which we use the letter m for, is always equal to your rise divided by your run. And again, I know that a lot of you have seen this. So your rise over your run. Y'all seen that before? right? So in this particular case, what would the slope of this line be? So if we were going to go from here to here, we would go up 1, 2, 3, 4, 5, 6. We went up 6, right? So that would be 6 over, and now we went to the right 4, so 6 over 4, which we could reduce that fraction. That's the same as 3 over 2, right? So the slope of this line is 3 over 2, 3 halves.
Would that be negative 3 over 2 or just 3 over
It's positive because we went up, right?
Oh, no, no.
We went up is positive, so rise, when we talk about rise, up is positive, and when we talk about run, going to the right is positive. Now, our answer is 3 over 2, but 6 over 4, we went up 6 and over 4, right? What if we went up 3 and over 2? 1, 2, 3, and then over 1, 2. We would still be on the line, wouldn't we? And then if we did it again, 1, 2, 3, and over 1, 2, see, we would be here again. 1, 2, 3, 1, 2. So we're always going to, so using this ratio of rise over run, we'll always land somewhere on the line, okay? Now, do you see this letter M? Did I use M earlier? I did use that, right? Look at the second form of a line, the slope-intercept form. Right? When I had this right here, that second form I gave you,
Yeah.
I used this M, right? That M was not just any number, okay? That is the slope of the line. Okay, so this is the slope of the line, and then this right here is the y-intercept. So what was the second line that I gave you? When I was giving you an example of this, what was the example I gave you?
Y equals negative 3x
Plus 4? Okay, yeah. Okay, so let's try and sketch this line. So remember, if we have a point on the line, then to get to another point, all we do is use the rise and run, right? Can you tell me just by looking at this what the slope is? So what is the slope of this line? What is M here? Negative 3, right? But we need to look at that as a fraction. So I'm going to put negative 3 over 1. Because that's negative 3, isn't it? Make sense? So this number always we always have to look at that number right there as a fraction. So that tells me right there that to get to another point, right? To get to another point on this line, I'm going to go, what? Down 3 into the right 1. That's how I get to another point. But I need a starting point. I need somewhere to start from. And this number, when you're written in this form, this number right here, you have to include the positive here, that is always your y-intercept. So let's try and do that example. Let's graph it right now. If you were asked to graph this line right here, what would be the first thing you do? Where would you start at? You first go to the y-intercept, right? You go and you use the 4. So remember, this is y and this is x. So I go up 1, 2, 3, 4. Here's 4. I put a dot. And then to get to another point on the line, I need to go down 3 into the right 1. So down 3, 1, 2, 3, and to the right, let's say that's 1, to the right 1, boom, like that. I've got 2 points. As soon as I have 2 points, I can draw a straight line. All right? There we go. We're done. So I'm kind of cheating here. Remember, you said, can you do it with just 1 point, right? Kind of. We did it with 1 point, right? But we still needed what to do the rest of it? We needed the slope, right? We needed to get that second point. So the slope gave us that second point. I do have a question, though. Why is that always going to be your y-intercept? Why is that number sitting out there always the y-intercept? Always, no matter what. Think back to the first method. That's right. Exactly. Remember the first method, we said to find the y-intercept, you set x to 0, don't you? So look at this equation. It has y and x in it, right? There's an equal sign. So we know this is a line. I'm supposed to set x to 0 to find the y-intercept. If I set x to 0, this will always be gone, right? And that'll be y equals that number. That's your y-intercept. So the number sitting out here by itself is always the y-intercept, regardless, so long as it looks like y equals mx plus b. All right, let's try something. Let's try something. Let's do the first line again. What was the first line I gave you? 3x minus 2y equals 12? We already graphed this line, and then we graphed this one just after it, right? When we graphed this line, we used the first method, which was the intercept method. And when we graphed this one, we used the slope-intercept form of a line, right? So we used the y-intercept and the slope, and we got it. I'd like for us to do it backwards now. I want you to use the method we used for this one, for that one. I want you to do this one with that method, okay? So let's see if we can understand what I'm saying here. In order to do this one, using the slope, I first need to make it look like y equals mx plus b. I have to make it look like that first. So how can I make it look like this? What's the big difference between this one and this one? The y is by itself, right? So in order to do this, I have to get y by itself. That's the first thing. So let's get y by itself. How could I get this? Let's start with trying to get this term by itself. So I need to get rid of the 3x that's on the left. So I would, in this case, subtract 3x from both sides. So subtract 3x here, subtract 3x here. It goes away. We're left with negative 2y equals, let me write it this way, negative 3x plus 12. Is that okay to do it that way? I could do 12 minus 3x, but I'm trying to get it to look like this, all right? All right, one more step. I need to get y by itself, not negative 2y, but y. So how can I get rid of the negative 2? Divide both sides by negative 2. So I divide this by negative 2, this by negative 2, this by negative 2, and that will leave us with y equals, okay, what is this going to be? Be careful there. Negative divided by negative is positive 3 over 2, right? So 3 over 2x. And then what about 12 divided by negative 2? Negative 6, right? Now, is that in slope-intercept form? Y equals mx plus b. Yes. Okay, so let's try and graph that then. To graph this, where are we going to start? Negative 6 on the y-axis, right? So we start at negative 6 on the y-axis. 1, 2, 3, 4, 5, 6. Here's negative 6. I put a dot. And then from that point, where am I headed? Up 3 over 2. So I'm going to use the rise over run here. Up 3, 1, 2, 3, over 1, 2, and there I am. And then I could draw a straight line, right? Now let me do it one more time. Let me go up 3 and over 2 again. 1, 2, 3, over 1, 2. Can y'all tell me what that point is right there? How much? Yeah, it is the x-intercept, but can you tell how far I've come over? I went up 3, over 2, and then up 3, and then over 2. Isn't that the same thing we had earlier? When we did it the other method, we found 4 and negative 6, didn't we? Here, we did it a different way. We could have just drawn this, and I'm trying to convince you that we drew the same line, okay? Now, if I were doing this problem and I were asked to graph this line, I would not do this. I would just do it the way we did it originally. I'm just trying to show you, how do you do this the other way? How about this one? How can I do this one the way we did that one originally? I actually don't have to move things around. I can just say, all right, I want the x-intercept. How do I find the x-intercept? Set y equal to 0, right? If I set y equal to 0, what happens? 0 equals negative 3x plus 4, right? Like that. And now you're trying to solve for x. So I'm going to add 3x to both sides. And then divide by 3. That makes sense? So, but we get a fraction, which is kind of ugly, isn't it? But this is my x-intercept, 4/3, 0. Now how do you find the y-intercept? Set x equal to 0. So I won't really need to go through much work for that one, because we already know what happens when I set x equal to 0, right? Set x equal to 0, you get y is 4, and we're done. So you get 0, 4. So graphing that line, let's see how the graph of this one doing it this way is different than the way we did that one originally. Am I moving too fast, or is this okay? You all right? Okay, so for this, my x-intercept is 4/3. How am I going to do 4/3? Like, what is 4/3? It's like 1.33333. Yeah, that's kind of hard to do, but let's see. If this is 1 and this is 2, it's like, it's about there. See, we would have to kind of eyeball this a little bit to get that. Do you agree? And then the other one, the y-intercept isn't so bad. That's 1, 2, 3, 4, 1, 2, 3, 4. That's there. And then we could draw our straight line through there. Like that. And that is the same line that we had from before. Okay, any questions on that? So if I give you an equation of a line, yes?
So when we do fractions,
Yes?
I mean, like, is it, we just put like an estimate? Like where
Estimate.
it's supposed to be, yeah, because
Estimate,
it's
yep.
very hard to,
Yeah, like,
exactly.
yeah, if this was like 3/2, that's 1.5. That's a little easier to graph because, I hope that you'd be comfortable that 1.5 would be right in the middle. But again, we are estimating. Unless it's a nice whole number like this, 4, then it's easy to put there. But otherwise, it's just ballpark. Okay. Let's look at some of the problems that are presented here and see if we feel like we could handle these. So when it comes to the exam, I do not care how you graph these, okay? Like, I'm not going to tell you one way or the other. I'm going to let you decide what you want to use, all right? There's 2 different ways, you choose. So look at this one right here. First of all, is that a line? 5x plus 2y equals 10. That's a line. Okay, so we want to graph it. So to graph all the solutions to that equation, we have 2 different approaches. So which way would you do in this case?
We'll just say one of the x and the y.
You want to just find the x and y intercept and be done? Okay, so let's find the x-intercept. Why don't you take just 4 minutes to see if you can do it. Last class, we did not get through all the sticks. So let's see. I'm going to call some names. Devon, Miranda, Victor, Aaron, Paris, Brianna. Did I call y'all last class? Did not. Okay.
You didn't call me last time.
How about Alyssa, Jared, Christine, Gia? I called y'all last class?
Yes.
Okay. All right. So this is the stack that still needs to go.
You're missing me.
I didn't mention everyone. I had 2 stacks, and I didn't know which was which. So I'm going to call on you, and I'm going to ask you for either the x or y intercept if you're in this stack here. If you need help or anything, raise your hand. Most of you done? Let's see, David? Where's David? Are you done? You were done like before, I think I even. Okay, so what'd you get for your x-intercept, David?
2.0.
X-intercept? Yes? Okay, so for the x-intercept, you set y equal to 0, which gave you the equation 5x equals 10, and you divided by 5 and got 2, so 2, 0, right? Okay, so you go out 2, 0, there you go. All right, let's see. Laura?
Yes.
Laura, did you get the y yet? The y-intercept?
No, I haven't.
Okay. It's okay. I'll come back to you on another one.
Okay.
Brianna? Is Brianna here? Wait, hold on. This is Brianna G.
That's fine.
Okay.
I think I got 5.
5? You think you got 5 or you know you got 5?
Honestly, I know
You know you got 5. Yes. Okay, good. I was talking to one of your classmates the other day about this stuff, and a lot of this stuff is just confidence. You want to believe that you can do this, so you got 5, so know it, own it. It's fine. There you go. Everyone agree? Okay, so that means the point is the point 0.05. And so Brianna, I'm going to go where from here, Brianna? Up. 1, 2, 3, 4, 5. And then now once we have 2 dots, we can just connect with straight line. All right? We good? All right. Let's see if these get any uglier. There, like that. Okay. So there's fractions now, and no one likes fractions except for me. Okay, there's different ways to go about this, all right? I would still stick with find the x-intercept, find the y-intercept. I would still do that. And the reason why is because in order to do the other method, I need to solve for y, and that's too many steps that I don't feel like doing. Does it make sense that that's my approach? But the fractions still bother me a little bit here. So what I would do is I would clear the fractions. In other words, I would look at all the denominators, 2, 8, 4, and try and find a common multiple of all of those, which in this case, what would be a common multiple of all those numbers? 8. So multiply everything by 8. So multiply 8 times 1/4 y minus 8 times 1/8 x equals 8 times 1/2. Understand what I'm doing there? Why am I doing that? What happens? What happens here? What does that really become? 8 over 4, which is 2,
Yeah.
right? So this is 2y. Okay, minus, now what about this? That becomes 8 over 8, which is 1. So that's just 1x. And then equals here, what's that become? 8 over 2, which is 4, right? So now you have the same equation. Believe it or not, the solutions to this equation are exactly the same as the solutions to this equation, because what you did was multiplied everything by 8, and when you do that on both sides of an equation, everything still maintains the balance. So isn't this equation a little bit easier to work with, right? No fractions, doesn't that look nicer? Okay, I'll give you 2 minutes. Get your x and y intercepts there. Yes.
Just so you know,
Uh-huh.
my Monopoly
Okay.
thing, so I'm just gonna rely on the video. Later.
Okay, yeah, it is.
Listening.
It's going, yeah, no problem. You have the x-intercept yet? Yeah, so if you want to find the x-intercept, right, you're going to set y to 0. Okay, so go ahead and write down here x-intercept or x-int after it. Okay, so that lets you know what you're about to do. Don't, just put like a semicolon or something there. That's just letting you know I'm about to find the x-intercepts, okay? So now set y equal to 0 here. So write down 2 times 0 times 0. And then minus x equals 4. Okay? And now this goes away, right? And all you're left with is negative x equals 4. And to make it positive here, multiply both sides by negative 1. So that'll make it, yeah, negative 1 there, negative 1 there. So you'll get a positive x here and a negative 4 on the other side. Does that make sense? Okay, so that's your x-intercept, right? Then to find the y-intercept, you're going to set x equal to 0 and do the same thing. Okay, Brianna, are you ready? Yes? Okay. What do you have for your x-intercept here?
I think I got 0 more.
Okay, so for your x-intercept, you set y equal to 0. This one can be a little bit tricky, right? Maybe because when you set y to 0, that's gone. You have negative x equals 4, right? You have to make it positive x. So you have to multiply both sides by negative 1 here. So if I multiply that by negative 1, I get x, and that by negative 1, I get negative 4. So you have negative 4, 0. That's your x-intercept. Let's see here. Paris? No Paris? Oh, Paris. There you go, Paris. Did you get the y-intercept yet?
2?
2? You know it's 2? You think it's 2? It's 2. All right, so to do the y-intercept, you set x to 0, which kills this off. That left you with 2y equals 4, and then you divided both sides by 2. Okay, so good. We get x was 0, y is 2. So when we put these 2 points, Paris, where do I put that point 0, 2? So I'm going to start here. Where do I go? Up 2. Okay, and then for the x-intercept, Brianna did that, right? Which way do I go here?
Down.
Down?
I mean, yeah, that's the left.
Left? Left 4? Everyone agree?
Yeah.
Yes. That's negative 4, 0. So the x is negative 4. You don't go up or down. This one, you don't go left or right. You go up 2. And then you draw a straight line. There you go. Okay? So if you're given a linear equation and you're asked to graph it and it has fractions, my recommendation is to just clear the fractions and work with this. I think it's easier to work with. Now, you could have still done it the other way. Okay? Just let x be 0. I'm sorry, to find the x-intercept, let y be 0, and then solve that equation. Just you're going to have fractions, okay? So if you don't mind that, go ahead. All right, let's do another one. But I'm going to make this one up. Just look at what else we got here. No, let's do that one. So what's different about this one? 5y over 2 equals 10. There's no x. Do y'all agree there's no x in this equation? I'm going to write it slightly different. I have 5 over 2y equals 10. So for this, there's no x in the equation. So you might say to yourself, well, then this isn't a line. Well, it is a line. What I need you to see is that there's actually in front of this, it's kind of hidden from you, but there actually is an x here, but the number in front of it is 0. So this is still a line, but you only have y involved in the equation. So let's try and solve for y here. Let's just solve this for y. So how could I get this 5 halves out of here? I'm going to erase this because it's distracting. How could I get the 5 halves out of there?
Divide by 2?
Divide by? There's 2 ways. You can divide this by 5 over 2 on both sides, or you can multiply both sides by the reciprocal 2 over 5, which is the way I prefer to do it. If you multiply by the reciprocal of a fraction, what happens? 10 over 10, right?
Yeah.
Which is 1. So that would just give you y. Then over here, you have to multiply these two. So look at 10 as 10 over 1 and multiply. What is that? 4. So y is 4. So what does that mean? What does that mean in terms of a graph of a line? It's saying y has to be 4, right? So would this point work?
Yes.
What is that point? What are the coordinates of that point?
0, 4.
0, 4. So is y 4 here? Yes. Right? The y is 4. All right, what about this point? Right there. What's that point? I don't know if you can tell. What's the x coordinate? 2, and what's the y coordinate? 4. So is y 4 there? Yes. What if I pick this point right here? Is the y 4 there? Right? So it doesn't matter what the x is, right? All that matters is that the y is 4. So every point on that horizontal line satisfies that equation. And so when you see an equation where you have y is equal to a number, you are looking at a horizontal line. Horizontal horizon, this way, right? Vertical lines up and down. Yeah, I'm sorry, horizon, horizontal. So if we had the equation, let me do it in a different color here. What if we had the equation y equals -3? Then how would you graph that? Go down 1, 2, 3 here and horizontal straight line this way like that, right? Okay. All right, what do you think, how do you think we do vertical lines? X equals a constant, right? X equals some number. And then if you draw a vertical line, every point on that line has the same X coordinate. So I think the next example is that right there. Yeah, look at that one. So what would the graph of this one look like? Where would I go to graph this one? You know what? Let me ask someone. Let me ask, where's Aaron Black? So Aaron, to graph that, you recognize there's no Y, right? So all of a sudden, like as soon as you see there's no Y, you know that that's a vertical line. Well, you're going to have to know that that's a vertical line, right? So Aaron, what next?
So you divide
Uh-huh.
by 8 on both sides.
Divide both sides by 8, and you get X is -2. So then over here, what would you do? Down 2?
I mean,
Uh,
right 2. Or left.
Left 2, yes. Okay, so left 2 because you're X, right? And then from there you draw straight up and down. Okay, so you draw a vertical line. Okay? Y equals a constant this way. X equals a constant this way. Anything else is going to have X's and Y's in it in the equation. So those are two very special lines, vertical and horizontal. Yes?
So, go back to a problem like that.
Yep.
So looking at that, like, how do you know that that's a linear equation? I think at the beginning of the class, you said it had to have 2 variables.
Great question. Great question. The question that's being asked is how do you know that that's a linear equation versus a standard equation from the beginning of class where you would just say that the solution is x equals -2. And the only way you would know is the way I'm presenting the problem to you. So here I'm asking you, well, the instructions are further up. So for these, it says graph the following lines, right? So it is saying, I want you to look at this solution, the solutions to that equation in 2-dimensional space as opposed to just on a single answer on a number line. Does that satisfy? Okay. Okay. So if the instructions for this were solve, your answer would be x is -2, done. But if it says graph the line, then you have to draw the vertical line. Okay? So it's in the phrasing of the question that you would know. Okay, so that leads you to the homework for that. And you're just going to have to practice doing what we just did in class to get through those. And then the way that this presents it, it breaks it up into 2 different sections. It does the first method, right? And then gives you homework, and then it gives you the second method and gives you homework. But I'm telling you, I don't care which method you use for those.
Okay.
Okay? So practice both and see how it goes. Yeah, okay, so we're not ready for that yet. We have more to talk about. All right, so now, let's talk about slopes of lines. All right, so I'm going to draw a couple of pictures here. I'm going to draw 4 pictures. When it comes to lines, and we talk about their slopes, we have 4 different scenarios when it comes to the slope. First of all, the slope, remember the slope is m, right? That number? If m is positive, greater than 0, if the slope is a positive number, you are guaranteed that your graph will look something like this. In other words, the slope will be pitched up as you kind of read this from left to right. Okay, it's going up. If your slope is negative, what do you think is going to happen?